Welcome to the Airlock IAM 8.4 release video. As usual, Mike and me, I'm Mark, are going to talk about the new features in the new release. In this video, we're going to talk about the shown features. Note that the video has chapter markers, so you can easily jump to the desired topic of interest. Airlock IAM 8.4 brings new config automation features. It's about a YAML config format, a concept called Snippets, and new config-related CLIs. Our ambition is the following. We want to empower customers to implement config automation with Airlock IAM seamlessly. We provide a toolset so you can integrate Airlock IAM into your existing configuration automation processes. Last but not least, we want to continuously improve our features by learning from customers and partners. So please talk to us and give us feedback. The first new feature is the new config format based on YAML, as you can see on the right on this slide. It's better human readable, it's better diffable, it's easier to adapt. It's also better accessible for tools like YQ and other command line tools, and easier to manipulate automatically. We allow you to use human readable IDs instead of UUIDs, which makes script manipulating config files a lot more readable. Where possible, we preserve hierarchical config structure also in the config file. This results in a config where semantically close elements are also together, which again makes diffing or comparing or reading such documents a lot easier than the XML variant. The new format supports all config concepts. By that, I mean configuration contexts, environments, configuration variables, and so on. Here is an example of a diff, which I made with my IDE. And what I did is I went to the config editor and I changed some properties within the Airlock2FA settings. The changes are in various plugins, but here you can see that the changes, they really stay together and are a lot easier to understand than in the XML configuration files, where these three changes would have resulted in three diffs that were spread across the whole file. Config snippets are an important new concept regarding config automation. You can store any part of an IAM configuration in a separate YAML file. This can be a plugin, a list of plugins, a plugin tree, or also a list of plugin trees. So it's totally up to you how much and what to put in a snippet. A snippet looks like a normal YAML configuration file. It just has a different type. It's called IAM snippet. Snippets allow you to modularize complex IAM configurations into several better manageable files. The snippet concept is supported by the config editor, and there are new CLI commands supporting snippets. Examples for things to put in a snippet could be a target application template, could be a whole target application, a second factor, flow templates, OpenID Connect clients, and so on and so on. Together with the new YAML format and the snippets, there come several new CLI commands that are used to automate config manipulation and config composition. So first of all, there's this validation CLI command. So you can, after putting together or manipulating YAML config files in a pipeline, for example, or in a script, you can also validate the configuration, so you can make the pipeline fail as early as possible if a configuration is not valid. There are new commands to connect plugins. By that, I mean to connect a plugin to a plugin property or a plugin property list or a plugin property map of another plugin. It is used to compose larger configurations from smaller ones in scripts. Then there's a CLI command to import a snippet or also multiple snippets into a larger configuration, again used for composition of YAML configurations. Then there's a CLI that allows you to convert XML to YAML. It's used mainly when you change an IAM instance from using XML to using YAML. Note that the new CLIs, they only work on the YAML. They won't work on the XML files, except for the conversion YAML, of course. So if you put that all together, you could do something like in the following example. You could, for example, store your IAM configuration and snippets and code used to manipulate and put together a configuration in a repository. Then use a deployment pipeline, which checks out, for example, a base configuration, which could form the basis of all your configurations with the main stuff put together and configured as you like. Then you could, in the pipeline, check out some snippets to compose something that is close to your target configuration for the system being set up or being configured. In this example, these are two target applications and a snippet containing some auth flows. After that, you get some code that is has been specifically designed to connect plugins from these various snippets and the configuration, and maybe also adapt and, for example, make adjustments to some database connections for the production system or add some secrets or whatever. So this results in your configuration that you would like to deploy. Then it is advisable to validate it first in the deployment pipeline before then sending it to the IAM deployment to activate. So to get more information about config automation features, please consult our documentation. In the chapter Configuration Management, there's a subchapter chapter Config Automation, which gives you all the information that you need. Then there's also a separate webinar video on config automation, which tells you in detail how the YAML format is made up, how to use and how to create snippets, and also how to manipulate YAML files using scripts. Please keep in mind that with 8.4, we released the first config automation features, so they probably won't fit all your requirements. So please provide us feedback so we can improve things over time. This section of the video is about improvements in the area of authentication. Let's start with FIDO passkeys. If you're using your FIDO key on your device, be it a mobile phone or laptop or a desktop computer, things can go wrong. Airlock IAM now offers a new REST endpoint where these things that can go wrong are reported to. In the current state of implementation, our login app UI reported the following failure types to Airlock IAM. It reports authentication failed if a timeout occurred, if the user aborted the authentication attempt, if authentication is not allowed for any reason, or if WebAuthn is not available in the browser at all. Reporting such failures has different advantages. First, the reason is written to the logs, so you can really now know what happened during a failed authentication attempt. This could be useful, for example, for the help desk to give a good advice to a calling end user. And more important, you can react to these failures in the flow. There's a new feature called on error gotos in the flow, which is explained later in this video. Just to give you 3 examples what you can do with it. For example, if a user tries to use FIDO passkeys and it doesn't work, you could then, after that, offer an alternative second factor by redirecting the flow to such an alternative second factor step. Or if WebAuthn is not available in the client for some reason, you could guide the end user and tell the end user what happened and then redirect the end user to wherever you want in the flow. As a third example, if a user actively cancels passkey verifications for some reason, maybe the passkey is not available or the user doesn't want to use it on that computer or whatever, you can then allow the user to change to an alternative second factor. Auto-generate display name is a new feature that allows you to automatically generate a display name during FIDO registration. So far in Airlock IAM, ever since a FIDO feature existed, the flow to register a FIDO key or a pass key was as follows. User has to choose a display name. By the way, the display name is used to re-identify your FIDO key among several FIDO keys, for example, in the self-management console. So the user first has to choose a display name, then the passkey is registered. Now it's possible, if enabled by configuration, that the display name is automatically generated based on the AHUID. The AHUID is something that is provided by the FIDO key during registration, and IAM can look up the make and the model of the key. So this make and model is then used to auto-generate a display name. And you can enable this in the FIDO settings by just ticking the box auto-generate display name. So the user can just register passkey without having to type in the display name. And optionally, you can add a change display name step, the new step, to allow the user to see that generated name and change it if necessary. Persistent transports. So what are transports and how are they used in FIDO? If a FIDO passkey is enrolled, then its public key is basically written into the IAM database with some other information. And during authentication, all allowed keys or all registered keys of a user are presented to the browser. And the browser pops up with a dialog, or also the mobile phone pops up with a dialog and lets the user choose the right passkey in the right mode. Now, even if the user has just a few passkeys registered or just one, there can be many options on how to use this passkey. This is called the transport. It could be used over USB, over NFC as an internal, like a fingerprint scanner, or hybrid, like using your mobile phone to scan a QR code from the screen of the laptop and so on. So this can be quite confusing, and in some situations it doesn't have to be. So the new feature, persistent transport, allows you to store the transport that was used during enrollment, during registration in the database, and then also send that to the browser when authenticating. This will eliminate some of the options. Ideally, there's only one left, and results in a lot better UX for the end user. The feature can be enabled in the FIDO settings, in the repository settings, and it's the default for new configurations. So existing configurations will behave exactly as before, but if you have a new FIDO configuration, then the feature will be enabled by default. This feature requires a database schema migration because it adds the transports field to the database schema. It can be combined with the authentication and proof of transport that are stored in the configuration. Please read the documentation in the config editor for more details about that. Let's switch to Airlock 2FA. What you see on this screen is the Airlock 2FA tab within the user management of a user in the Airlock IAM admin app. It is now possible to display a 16-digit code that allows a user, by entering it into the phone, to enroll an app or a device. To be able to see this code, the logged-in admin has to have the new privilege view Airlock 2FA activation secret. Very similar to the Airlock 2FA feature just presented, in Cronto, you can also now directly display the cryptogram for activation of a new phone in the admin app. Again, here, the logged-in administrator has to have a new access privilege called view Cronto activation secret. Let's move on to OIDC OTP. Now there is an enrollment self-service for end users. So what again is OAuth OTP? It's the app-based OTP login possibility for OTP generators like Google Authenticator and many others you can download freely from the app stores. So to initialize or enroll an app, you have to scan the QR code, or theoretically, you can also enter a very long code manually. And this was so far only possible by using a QR code letter or by displaying the QR code in the admin app. Now there are steps to display this enrollment QR code in the self-service flow. It is available for self-registration flows, for protected self-service flows, and for auth flows. The latter can, for example, be used for migration from SMS to OATH or to add another factor during the login with username and password. This section of the video is about generic new flow features. These are features that are applicable to all flows in Airlock IAM. Let's start with the configurable on-failure go-tos feature. So far, if a flow step failed, this led to a flow abort, and if it was about an authentication factor, it increased the corresponding counter. The new feature allows to define a go-to target per step and per failure type. Here's an example. We are inside the configuration of a FIDO authentication step here. The FIDO authentication step defines the following 5 error types or failure types on the left, like FIDO authentication aborted and not allowed, and so on. On the right side of this configuration, there's a go to target. It points to another step. So this configuration would tell when you're in the FIDO authentication step and the error type is FIDO authentication aborted, then go on in the flow with the FIDO alternative step. The same is for the second line, but in the third line, if the failure was a timeout, then go to the FIDO inform retry step. For example, informing the user what happened during a timeout and that he can try again, and so on. So you can redirect the user in the flow instead of getting a failure and aborting the flow. By the way, failure counters are still increased to keep up security. If failure counters would not have been increased, then this would open the door for attacks. Let's have a little bit a closer look at this FIDO example. Here is a flow. I'll explain the flow shortly. So we start with a user identification step on the left. The user enters the username or user ID. Then there is a selection called FIDO branches, and there's 3 different options. So the top one is the default option. This is automatically chosen. It's the only one that can be chosen. So the user doesn't have a choice which way to go. It will always be the top one by definition of the configuration. Then the other 2 flows, they are not selectable by the user, but they are here that we can go use them as go-to targets. So when you remember the configuration from the previous slide, we defined in the FIDO authentication step from the default option that if, for example, the error code is FIDO WebAuthn not available, then we will go to another step. And in this case, this is the email OTP step as an alternative to the FIDO step. Similarly, if there's no valid token, if the user doesn't have a passkey registered and cannot do FIDO authentication, then we would redirect the user to the FIDO registration branch, which would ask for an email OTP and then asked to register a FIDO passkey. So how do you know about the error codes of each step? They are documented. On selected steps, like the FIDO step you saw, it's in the plugin property. So you can look this up in the config editor. And for almost all plugins, it's in the REST API specification. So have a look at the general error code sections. These are general error codes that are valid for all steps. And in the specific endpoints, here is again the example from FIDO. The on-failure go-tos are especially useful when IAM is talking to peripheral systems and cannot reach them. By peripheral systems, I mean like something like calling an email service, calling the Future A service, an SMS provider, or any other system that is contacted over the network. So in a case such a system cannot be contacted, a connection cannot be established, or whatever happens, what can you do here? So in the middle columns, you see what happened in previous releases, and in the right column, you see what is happening and what is possible with 8.4 and newer. So in the older releases, if that happened, if, for example, the email service could not be contacted when sending an email, an exception occurred, and HTTP 500 is responded in the REST API, and then static error page is shown. You cannot recover from this, and it counted as a failed attempt when you were inside an authentication flow. This may have locked out users, and they cannot do anything about it. So with 8.4, some things have changed. Now, this is not treated as an exception anymore, but the step will fail with a specific error code, which is external service unavailable. Also, the REST API will respond with 403 and no longer 500. Note that this is not a breaking change for REST clients because all steps have already had the possibility to respond with 403. So if you do nothing, if you do not configure any on-failure go-tos, then now the flow start page will be shown with an error message and not a static error message. But if you want to use the on-go-to failure, on-failure go-to feature, you could also do something meaningful. In some cases, for example, if the email server cannot be contacted in an email OTP case, you could, for example, offer a different way to authenticate the user. And last but not least, if this happens, it does no longer count as a failed attempt. So users don't get locked out in such cases. So with this, I'm handing over to Mike, who is going to tell something about events in flows.
Generic step result events are a new feature in the login app flows. Every step will now create an event, and you can configure a subscriber to pick up on those events. What does that mean? Well, with every REST response, we're not only sending REST response to the client, but we're also creating such an event. As I mentioned, in the subscribers, you can collect those events and you can filter to make sure that you're only receiving and processing those events you're really interested in. And the filter is quite extensive. You can go for a particular step, or you can have all the steps in one flow, or all the steps of a particular flow type react to this particular subscriber. There's two words of warning. Number one is they're only available in login app flows. Of course, because steps are only available in login app flows. And the second word of warning, please check carefully if we do not already provide a specific event for what you're trying to achieve, because the specific events have the advantage that they're not only generated in login app flows, but also in the remainder of the login app. And this may be actually more useful in certain circumstances. So this is it about generic step results events. Let's discuss another new feature, which are custom attributes. Every time we're sending information from IAM to the client, we're adding that information in the REST response that we're sending. And there's several different types of information that we're providing. The first one is message-specific attributes, basically things like identifiers. Then we're adding additional attributes that depend on the step and the flow state. For example, the next step information belongs into this category. And now, new, we can add custom attributes, which basically you can configure on every single step on what information shall be supplied. An example here, how the configuration is done. You see that down here we have the custom response attribute, which will be sent in a success state. And I have added here the user statistics map, which we'll see an example later. And what you also can configure is what to do in a failure state. So you can add custom failure response attributes. As promised, let's look at these user statistics. I have a small flow. It has a previous step, then there is a mandatory password change, and then we have a following step. And the important part, of course, that interests us is here in the data that we're returning, we have custom attributes. And as you can see, these user statistics before the mandatory password change are fewer than after the mandatory password change. Why? For example, here the attribute first login, which is a timestamp, only exists once you actually use the password. And since this is the mandatory password change, it's probably the first time this user actually logged in. Special properties of custom attributes is the error handling. Yes, custom attributes are provided. They're defined in a separate configuration, but they're embedded in the meta blocks. So they're not part of the regular data, which we don't return in error handling, but they're directly in the meta block. You can find them here on the screenshot. The second thing that's a little bit special about custom attributes is there's non-interactive steps. You still can configure custom attributes on those steps, and we will collect them for you, and we will them with the next REST response that we're actually sending back. If you have several times the same information that you're returning, then of course the last instance will win, and that's the information that the next REST response will return. Context retention policies are a feature that IAM has since many years. With the migration to the REST API and REST architecture of IAM, we have focused on bringing this feature back, and we've implemented context retention policy based on requests. What does that mean? If we're looking at the flow here in front of us, then the context extractor is evaluated for every single step, and the context is determined at every single step. Now, it's a limitation of the login app that changing context during a flow is not possible, because it wouldn't be non-deterministic what is actually going to happen. So this is a method that works very well if you're having a URL context extractor where you're matching for the vhost, for example, or an IP context extractor in a situation where the IP address remains consistent. Now, what we added with IAM 8.4 is we're bringing back the context retention policy session. The idea is that the context is only evaluated once at the beginning of a flow and then remains the same for the entire flow, regardless of actually what the context extractor says. To make it even more flexible, we're allowing you to determine on whether changes are allowed during the session of a user or not. If you say it's off, then once it's determined that the context remains the same for the entire session. If you're saying that, yes, we allow changes, then at the beginning of every flow, the context is re-evaluated, and if a different context appears, then this is okay. This is particularly useful with the HTTP query parameter context extractor, where you could do things like you add a query parameter like context equals blue, and you start then a flow with that in the UI call, and the entire flow will be run in context blue. With the next flow, you could have a query parameter that says context equals red, and of course then the second flow would be run in the new context red. So this is hopefully a very useful feature for you with the new session context retention policy. As with every release, we've again improved OpenID Connect, and this time we've added delegation to the token exchange. We've made the client credentials count a little bit more flexible, and we've improved performance in certain situations. So let's talk about token exchange. To understand delegation, we kind of compare two use case scenarios. It makes it a little bit easier, I think. The first thing is we have an external identity provider which needs or issues tokens that we want to transform into tokens used internally. This is something that we're already supporting since quite a few releases, so I'll not go into too much detail with that. The second scenario is that we have a help desk user that wants to act on behalf of the user. Now, if your application supports that, fine, you don't need to do anything. The help desk user logs in and it just basically says, I need to act on behalf of that user, and you're done. If the backend application doesn't support it, then token exchange could be a feature that you could use to kind of enable the backend application for this type of scenario. What you do is you generate a token where the subject is actually the user and the actor information on who's actually sitting at the keyboard is again also added to the same token. So in login situations, you can actually log the subject, the end user, and the help desk administrator in one simple log line. How does it work? As I said, to understand a little bit better, let's look at the regular token exchange situation. We have here a user sitting at his client. He has used an external identity provider to authenticate, issued a blue token. You go to your internal token exchange, turn that blue token into a red token, and that red token is consumed by the service here on the right-hand side. So far, so simple. In the delegation scenario, we already see from the colors that it's get a little bit more complicated. At the keyboard here, we have this green guy, which is our help desk administrator, and he's looking at the user, again represented with the blue token. When we send these two tokens to token exchange, what we expect back is a red token that also contains the information about the help desk administrator. So in this scenario, the backend application sees the red user, does authorization and everything for the red user, but still has the information that the green user actually is acting on behalf of the red user. So this would be the token exchange delegation situation. What are the properties of delegation? Well, token exchange now supports both subject and actor tokens into a request, and will also use them to generate the resulting access tokens. To make this more useful, we actually have now two types on how we're dealing with those source tokens. The first one is claim extraction, which basically means we're taking the token, we're extracting the claims, but we're ignoring signatures if they exist. We even process it if it don't exist. The full validation is what we know from the past. It actually extracts the claims, but it also takes the issue statement, retrieves the JWKS information, and then validates the signature on the token. And if the validation of the signature fails, then the token exchange will fail. So this is it about delegation in token exchange. Let's talk about client credentials count. As I said, it's a little bit more flexible. Access tokens can now be configured with issuer claims, and they can be configured with audience claims. This makes us a little bit more compliant to the standards. And there's actually products out there that require that information in tokens issued by the client credentials grant. So for those of you who have been waiting for this feature, I hope this helps. Performance. You can use the grace period feature with token refreshes, and this can multiply the number of tokens in the database. What's the use case scenario and why this happens? Well, if you have one of these modern clients Those modern clients don't actually do one request at a time. They actually do many requests in parallel. And if this happens when your token has expired, then it can be that every single of these threads gets the response back that the authorization didn't work, and they will use the refresh token to refresh. So this could lead to a situation where you have several new access and refresh tokens issued almost in the same millisecond. Now, this is where the grace period comes in, so that we can actually deal with that situation and clean it up. And by using the grace period more sensibly than in the past, by updating refresh tokens to expire much more quickly until the grace period expires and now until their lifetime expires, we're actually, depending on the scenario, dramatically reducing the number of tokens. We have had made analysis, and in one situation, this was a reduction in the number of tokens in the database by about 80, almost 90%. Now, the nice thing is this is under the hood. If you're upgrading to IAM 8.4, it will just do it and will use the new policies. There's no configuration involved, and over time you will see that the number of token will actually shrink. The other performance improvement is if you're using IAM as an OIDC discovery client, then the caching of OIDC discovery responses, it was not supported correctly. Now it is supported correctly, and this reduces the amount of calls to the discovery endpoint tremendously. So I hope this will help those customers that were affected by that situation. Let's talk about usage analytics. The goal for usage analytics that we would like to collect information about the usage of products because we think it is important to understand how you're using our product to really improve those parts of the product that create the most benefit for you as a customer. Don't worry, when we're talking about usage analytics, of course, we're not going to collect all of that data without your consent. It requires the explicit consent of you as a customer before we start any data collection whatsoever. How does it work? Well, it actually starts here in the middle. When somebody logs into the admin app and connects to IAM, authenticates, and is fully authorized, then IAM checks on whether there is usage analytics data that needs to be transmitted. We're doing that at most once per day. And when we create such a package, we store it locally in IAM. There is a configurable location where that information is stored, so you can actually look at it in clear text to see exactly what kind of information we're transferring. If such an information package needs to be transferred, then the admin app will connect to the Azure cloud and upload that information. The information is object encrypted, so even if it was intercepted in transit, it's still encrypted. Nobody can decrypt it. And of course, everything works over TLS, so we can guarantee the security of the information. Now, what's in scope? Currently, we're only doing license analytics, meaning we return the number of users in your database. We return the license as it is installed on this particular system. And we're also returning the configuration of the usage analytics plugin. Usage analytics actually is a plugin that you configure on the level of the login app, and I hope you will do that. Now, apart from license analytics, which we're already returning this release, the next release will include usage analytics. This will then have information about the configuration, about the properties file, and about the database schema, because that also will help us to understand on how you're using our product. And of course, it's important to understand that if we want to improve it. So this is it about usage analytics. Let's look at some smaller features that we added to Airlock IAM in the 8.4 release. The first thing we'll discuss is our OpenAPI specification has been enhanced. In the past, it only included requests. Now we're including requests and responses. And of course, we've tested that with gateway and micro gateway. And to support the new OpenAPI specification, and will filter the traffic that goes to IAM and comes back from IAM. We've also added the documentation into the OpenAPI specification. So yeah, if you have some tooling to help you with your REST APIs, then the documentation will help you to understand what actually our REST API will be doing. For those that are in Kubernetes environments, the configuration editor is now also available as a standalone deployment, which may be helpful to you guys. And last but not least, we've been asked to add email OTP support for transaction approval. And yes, we did do exactly that. The next thing may be actually small in implementation, but may have quite a big impact if you're more on the operational side. We've changed our way how we define a fatal error. In the past, we were very much focused and we only reported fatal errors if IAM itself had a serious problem. Now we've expanded that definition and we're reporting fatal errors if IAM is no longer able to perform its task. Why is that such a dramatic change? Well, now we're reporting fatal errors if, for example, we can't reach the database or the Redis connection returns errors, or if we cannot reach LDAP or Active Directory. If we're running out of memory, out of disk space, we'll report that as a fatal error. And if important second factor authentication services are not reachable, like Future A, SMS Gateway, or email server, we're reporting that as fatal error. All these messages here are actually additional, so there's no need to change anything. If you were not interested in the past, you can just ignore them. The caveat is that there is needed changes because a failing config activation is now also reported as a fatal error. And if you're using password end-to-end encryption with AWS KMS, then those connection errors have changed to now report on the fatal error, fatal log level.
In the login app, it is now possible for the end user to show the password that the user typed in. So the user can click on the eye symbol to show the password and click again on it to hide it. This feature is not enabled by default, so nothing changes for existing login app configurations. It can be enabled by using a new SAS variable in the login app design kit as shown here on the slide. Airlock IAM 8.4 now supports more options to connect to Redis. Redis is the external session state storage supported by Airlock IAM. As before, the single mode Redis state repository plugin can be used. It's a simple plugin and it can talk to one Redis node. Now there's a new plugin called Expert Mode Redis State Repository. This plugin is a lot more flexible and it can talk to multiple Redis nodes. The following table summarizes the different modes and what is supported by IAM and what not. So to use Redis in single node mode, so just talking to one Redis node, use the single mode Redis state repository. If you want to use the Sentinel mode of Redis, then you have to use the expert mode Redis state repository. If you use the Redis mode called replication, there are two possibilities. The replication mode can be set up in such a way that you just talk to one single Redis node. There you can still use the single mode Redis state repository. And replication can also be set up in multi-node mode. So you talk to several nodes. There you have to use the expert mode Redis state repository. The cluster mode is not supported by Airlock IAM. Last but not least, let me give you some general release information. So when upgrading from 8.4 or an earlier 8.x version, you don't have to do any manual steps if using existing features. If using the FIDO transport persistence feature, you have to update the database schema. It is recommended to update it anyway, but it's only mandatory if using this feature. The release notes, you can find them as always on https docs.airlock.com/IAM/latest, and then navigate to release notes in the navigation of the documentation. There are also a list of actions required when updating, and these are really details you should go through, but you are very likely to not have to do anything when upgrading. So here are some technical data on the release. It's released end of March 2025 and supported till end of 2026. It's a long-term support minor release. The documentation can be found on the docs.airlock.com/IAM/8.4 or also /latest, as long as it's the latest release. And you see the link to the Academy. And just to remind you, official supports for 8.1 to 8.3 ends as indicated here on the slide. The next release, which we call 2025 fall, until we know what it's really called, it is planned for this fall, meaning end of September or beginning of October 2025. So with that, thank you very much for watching and listening, and hope to see you next time again. Bye-bye.